Hello friends. In this class we are going to discuss about Kirchhoff's laws of electric current. What is the importance of Kirchhoff's laws? Basically, Ohm's law and Kirchhoff's laws are used to find the electric current in a closed circuit. Ohm's law is useful for simple circuits only. And if you want to find the electric current passing through a circuit, a complicated circuit, we need to use Kirchhoff's laws. So, Kirchhoff's laws are of two types. The first one is the junction rule. Let us try to understand what is a junction. A junction is a point where three or more conducting wires meet. So here we have a junction. If you observe carefully, six conducting wires are meeting at one point. So this is called a junction. And let us try to understand what is a junction rule. What the junction rule says. The algebraic sum of the currents at any junction in a circuit is 0. In other words, we can also say like this. The current passing towards the junction is equals to the current passing away from the junction. Let us try to understand this. This junction rule can also be written like this. So sigma I is equals to 0. And here the currents which are passing towards the junction will be taken as positive, and the currents which are passing away from the junction are taken as negative. Let us apply this to this junction. Here we have the I1 current passing towards the junction, so the I1 will be taken as positive, and I2 current is passing away from the junction, so I2 will be taken as negative, and I3 also passing away from the junction, so this can also be taken as negative, and I4 current is passing towards the junction, so this can be taken as a positive. Same like that, the I5 is passing away from the junction, so this can be taken as negative, and the I6 current is passing towards the junction, so this can be taken as positive. So the sum of all these currents must be equal to 0. So this is what the junction rule says. This can also be written like this. If you classify the currents which are passing towards the junction, that means the I1 current is passing towards the junction, and I4 current is also passing towards the junction, and the I6 current is also passing towards the junction, and this current will be equal to the current passing away from the junction. So I2 current is passing away from the junction, I3 current also passing away from the junction, and I5 current is also passing away from the junction. By this we can say that the amount of current passing towards the junction is equal to the amount of current passing away from the junction. So by this we can easily say that this junction rule is based on the conservation of electrical charge. And now let us try to understand the second rule of Kirchhoff, that is Kirchhoff's voltage rule. Let us try to understand what the voltage rule is and what it says. So, the voltage rule says that in any closed circuit, the algebraic sum of the products of the current and the resistance of each part of the circuit is equal to the total EMF in the circuit. Here we have a closed circuit. This closed circuit contains three parts. That is, these parts can also be called as loops. So A, C, D, B, A. This is one part. C, E, F, D, C. This is another part. And we have third one also, A, E, F, B, A. So these are the three parts we have in this closed circuit. In this closed circuit we have three resistors, that is, this is R1 and this is R2 and this is R3. Here we have two batteries connected, and now we need to apply voltage rule for this closed circuit. Before that, we need to know the sign conventions for this circuit. What are the sign conventions? That means how the EMF should be taken and how the potential difference across the resistor will be taken. Let us try to understand about the EMF of the battery. And here, how the EMF of the battery will be taken. Let us try to understand this. What are the sign conventions for the EMF of the battery? For example, when we are moving from the negative terminal to the positive terminal, that means at first we are moving from negative terminal to the positive terminal. So in these type of cases, the EMF of the battery will be taken as positive. And when we are moving from the positive terminal to the negative terminal, in these type of cases, we take the EMF of the battery as negative. And in the case of potential differences across the resistor, how the sign conventions should be taken, let us try to know. And here, when we are moving along the resistance, that means when we are moving along the direction of the current, that should be taken as negative. And when we are moving opposite to the direction of the current, that should be taken as positive. Let us try to understand, let us try to apply these sign conventions for each part of this closed circuit. And let us try to take the first part of this circuit. That means A, C, D, B, and A. This is the first part of this circuit. Let us try to apply these sign conventions to this part. And first, we have to move from A to C. In between these two, there are no batteries connected and no resistors connected. Between C and D, we have one battery and one resistor. The first, the battery. How the sign convention should be applied for this battery. Let us try to know. So here we are moving first from the positive terminal to the negative terminal. So when we are moving from the positive terminal to the negative terminal, so the EMF should be taken as negative. So here we can write like this, that is minus E2, and then we have a resistance. R2. That means this is the direction which we are moving, and the current is passing opposite to the direction of C and D. So, so when we are moving opposite to the direction of the current, the potential difference will be taken as positive. That means the potential difference is nothing but it is the product of the current and the resistance. So I2 is the current and R2 is the resistance. So this will be the potential difference. And then between D and B, we have no batteries and no resistors connected. And between B and A, we have a resistor and a battery. So across this resistor, we need to find the potential difference. The potential difference is the product of current and resistance. That means I1 and R1. So here we are moving along the direction of the current. That means the direction we are moving in the same direction. That's why this potential difference will be taken as negative as per the sign convention. So we write minus, and the potential difference is product of current and the resistance. And then we have a battery here, E1. So here we are moving first from the negative terminal to the positive terminal. So the EMF of this battery will be taken as positive as per the sign convention, that is plus E1. This must be equal to 0. So this is the voltage rule. We can also write like this. So I2 R2 minus I1 R1 is equals to E2 minus E1. This is what the voltage rule says. The product of current and resistance must be equal to the algebraic sum of the algebraic sum of EMFs in a circuit. So like this, we can also apply these sign conventions to the second loop and also the another loop. So this is the voltage rule. By this we can say that the voltage rule is based on the conservation of energy.